today's lesson is lesson 2-3, solving more complex equations. Some equations require multiple steps to solve them efficiently. Let's take a look at the equation 3x minus 2 times the quantity x plus 3 is equal to 5 minus 2x. It is being solved here in the table below. Let's go ahead and complete the table by stating a property or providing an explanation for each step. Before we go ahead and start, just remember that an equation includes the product of a number and an expression in parentheses. You can simplify by applying the distributive property. Just remember from lesson 2-1 that the distributive property says I can take the number outside of the parentheses and I can multiply it to each of the terms inside, preserving the addition or subtraction between them. All right, so the first part of our table here would just simply be our given problem. This was the problem that we were asked to solve, or this is the original problem. Both of these are adequate explanations. Now, it looks like what they've done here is they've gone ahead and they've distributed the 2. 2 times x gives us 2x. 2 times 3 gives us 6. The reason we're seeing a minus here and not a plus is because of the minus right here. We're actually not just distributing a 2, we are distributing a negative 2. So it's negative 2 times x, negative 2x, and then it's negative 2 times 3, negative 6. But this is simply the distributive property. All right, now it looks like they've gone ahead and gone from 3x minus 2x to simply just x. Everything else seems to be exactly the same. So they've gone ahead and they have simplified, or they've well, actually I would say no, they've combined like terms. You want to have your two sides of your equation balanced. Notice right here in this step, I have 2 terms on the left and I have 2 terms on the right. These are balanced. Notice in the prior step, I have 1, 2, 3 terms on the left, but only 2 on the right. This would mean that I would more than likely have some like terms that I can go ahead and combine. All right, I'm seeing this. I'm seeing this. I'm seeing this. I'm seeing this. Everything that's the same. Things that are different are this positive 2x that they've added to both sides. This is the addition property of equality. It says I can add the same thing to both sides. Then they've gone ahead and combined x plus 2x to be 3x because remember there's an invisible 1 right here. And they've gone ahead and they've canceled these 2 out, giving us 0, which does not have to be there. They've gone ahead and simplified. You could also say they combined like terms. Just notice what's different. This is the same, this is the same, this is the same. Here's my difference. Once again, we're adding positive 6 to both sides. So this once again is my addition property. Okay, then you'll notice that they've gone ahead and they've combined this, they've canceled it. Sorry, they've canceled this, leaving us just with the 3x, and then they've gone ahead and combined 5 plus 6 is 11. They've gone ahead and simplified or combined like terms. Then they're going to go ahead and divide both sides by 3. This, of course, is the division property of equality. And in the last and final step, they have actually divided, and this is simplify, giving us our solution of 3 2/3. Let's go ahead and solve the following equations. We are going to verbally state the property of inequality and or provide an explanation for each step. You can eliminate fractions. When we get to C and D, we're going to talk about how we can eliminate fractions in an equation. We can do this by multiplying both sides of the equation by the least common denominator of our fractions. Okay, let me go ahead and zoom in here because I don't have much space and I want to try to get these two solved right up here. All right, we've got our x on both sides. So remember, you're going to take the smaller of the two x's and you're going to move it to the other side. Since 3 is smaller, I'm going to go ahead and cancel out the 3. There we go. Using the subtraction property of equality. Since I did not cancel out this subtraction, it has to now become a -3. This minus from that subtraction is now going to become a negative minus. Okay. I've gone ahead and simplified, and now I have my two-step equation. Remember, you're going to go ahead and get rid of your add or subtract first. I'm going to go ahead and move my answer up here. -3 and -8 would give me -11. And to get rid of the 2 because it's right in front of the x, I'm going to go ahead and divide. There we go. It's going to stay negative since there is only one negative. Two negatives is what I need to make a positive. I would say a -11 over 2. -11 over 2. All right, let's take a look at this one. Let me see. I'm going to go ahead and make my pen a little bit smaller. Maybe that might help. Okay, so the first thing I notice here as I highlight my y is that it is in parentheses. I am going to have to first distribute, giving me 8y plus 6 is equal to 16. There we go. Now I have a two-step equation. Once again, I'm going to get rid of my addition by using the subtraction property. I'm actually going to go ahead and subtract. This is simplifying. And then lastly, I'm going to use the division property to get the variable y by itself. And I'm going to go ahead and simplify. Since 10 and 8 are both even numbers, I know that 2 divides in there, which would give me 5/4. That is my final simplified answer. Let's go ahead and take a look at what happens when we have fractions. I'm going to go ahead and zoom back out because I think I have enough space down here. All right, now for C, I'm going to go ahead and I'm going to copy it down over here. And I'm just kind of looking at the fractions. And the part of the fractions that I'm looking at are the denominators. So I'm going to come back over here to the original problem. And I'm just going to go ahead and I'm going to highlight my denominators, the bottoms of my fractions. What I notice is that 2 of them are the same and 1 of them is different. Since 2 of them are the same and one does not have the variable and the other not, they both do not have the variable, I'm going to go ahead and leave my fractions. Now this is just a choice that I can make because I can see that my fractions are going to not give me such a headache. Okay, I know that I can go ahead and subtract the 1/5 from both sides. And I remember from elementary school that when fractions have the same denominator, I can go ahead and subtract. So I'm going to go ahead and do that. I'm just going to go ahead and say 4 minus 1 is 3, and the fifth stays in the bottom. I'm just remembering my rules of how to add and subtract fractions. Now remember, we've already talked about how to get rid of a fraction that is in front of a variable like p. We're going to go ahead and we're going to multiply by the reciprocal. This is going to go ahead and cancel out my fraction. What I do to one side, I must do to the other. So my fraction is gone, leaving me with my variable of p. And on the other side, I simply have to remember how to multiply fractions. Remember, you multiply numerator times numerator. 3 times 3 is 9, and denominator times denominator, 10 times or 5 times 2 is 10. We want to make sure that this 9 over 10 is simplified. Yes, it is. 9/10 is simplified. That is my correct answer. Let's go ahead and take a look at D. Here I notice that I do have two that are the same, and then I have two that are not the same. So I'll use another color. There we go. What I'm noticing about the two that are the same is that I cannot combine them together. Notice the first four, the first denominator of 4, has the variable a with it, and the second one, the second denominator of 4, does not have the variable a with it. So I'm going to go ahead and I'm going to use their tip of multiplying by a number to make the fractions disappear. So as I recopy this, I need to think of a number that is a multiple of all three of those denominators. What is a multiple of 2, or sorry, of 4, of 6, and of 3? It has to be a multiple of all of them. Now, there are a couple that come to mind. Um, and the first one that I think of is 12. 3 times 4 is 12. 2 times 6 is 12. I can go ahead and I can multiply both sides by 12. So I'm going to come in here and I'm going to say times 12 times 12 times 12 times 12. If I use the multiplication property, as long as I do it all the way through the problem to every single term, I'm not changing my values. Remember, when we multiply, we can say 4 goes into 12 3 times, and we're going to multiply 3 times 3, 9a. 6 goes into 12 twice, so this is 1 times 2, or 2. 3 goes into 12 4 times, so this is 2 times 4, or 8a. And lastly, 4 goes into 12 once again 3 times. This is 1 times 3, or 3. Now I have gotten rid of all of my fractions, and I don't have to deal with them like I did in Part C. Going back to Part C, because 3 and 5 are different, I would multiply by 15 because 3 times 5 is 15. So if I multiplied every term by 15, it would make all of my fractions disappear. All right, let's go ahead and move our smaller a value term to the other side by subtracting it since it is positive. This is the subtraction property of equality. That leaves me with 1a minus 2 is equal to positive 3. Now remember, when the 1 is in front of the a, it can be invisible. It doesn't have to actually be there. So all I have to do to finish this problem is move the 2 to the other side using the subtraction property of equality. I can drop the 1 because it can become invisible, and I can say that a is equal to 5. All right, let's go ahead and model mathematics. Bags of maple granola cost $2 more than bags of apple granola. The owner of a restaurant ordered 6 bags of maple granola and 5 bags of apple granola. The total cost of the order was $56. Let's go ahead first and let M represent the cost of a bag of maple granola. Write an expression for the cost of 6 bags of maple granola. It would simply be 6 times M, right? Let's go ahead and use the variable M to write an expression for the cost of the bag of apple granola. Well, I have to go back up and read that the maple costs $2 more. So if I'm talking in terms of apple, it's going to cost $2 less. So I need to go ahead and subtract 2. Let's go ahead now and write an expression for my cost of the 5 bags of apple granola. Well, I would simply multiply the 5 times what they cost, which would be this right here, right? Just like we did 6 times M, we're going to do 5 times the cost of the bag. And last but not least, we're going to go ahead and write an equation to show that the cost of 6 bags of maple granola and 5 bags of apple granola was $56. So we're going to say 6M plus 5M minus 2, I almost forgot my parenthesis, is equal to 56. Now we're going to go ahead and solve. Let me see, I think I have some space right over here. The first thing I would do after drawing my line and noticing that I have two variables m is seeing that the second m is in the parentheses. So I'm going to go ahead and distribute the 5, giving me 6m plus 5m minus 10 is equal to 56, okay? Because 2 times 5 is 10. Now I can see that I have two variable m's that I can go ahead and combine together to give me 11m minus 10 is equal to 56. Now I have a two-step equation. I do see subtraction this time, so I'm going to use the addition property of inequality. There we go, to get the 10 to the other side, giving me 66. And lastly, I know that there's multiplication hiding there, so I'm going to go ahead and divide. I'm going to say 6 is my answer. Well, what does that mean? That means my maple granola costs $6 and my apple costs $4 because it is 6 minus 2, right? $2 less.